lesson 23. We're also going to be doing lesson 24 as well. But we're going to start off with factoring polynomials. It means breaking it down to its prime parts. To completely factor a number means to express it as a product of prime factors. So the very most basic things that go into it. You know, so if you were breaking down 4 into primes, you would get 2 and 2. All right, you see an example here of 18. 18 is made up of 2, 3, and 3. Okay, or 2 times 3 squared. Similarly, to completely factor a polynomial of 2 or more terms means to express it as a product of prime polynomial factors. A prime polynomial is a polynomial that cannot be factored. It cannot be broken down any further. Okay, so we're looking for factors that can't be broken down any further, even if they are smaller polynomials. We want to use what we know about multiplying polynomials to end up factoring them. So if we know how to multiply polynomials, we should know how to break them apart again. Okay? The same way, if you know anything about multiplication, you should also know something about division. As the first step in factoring any polynomial, you want to factor out the greatest common monomial factor if it is anything other than 1. Okay? All right. So the following table shows some useful factoring strategies to try after factoring out the greatest common monomial factor if it's anything other than 1. And so we see some patterns that exist here. So if I have like a basic quadratic trinomial where I've got x squared plus bx plus c, I can break that down into, you know, the x plus u, x plus v. Basically what we're looking at, and don't get confused by the u and the v and where did those come from. What they're saying is that if it is plus plus in my factored form, it's going to be plus plus. Okay, so if I see something like x squared plus 9x plus 20, all right, I should be getting plus and plus in there. Okay, so now I'm looking for two things that add up to 9 and multiply to be 20. That's 5 and 4. Okay, so do we see what they're talking about there? All right, here, let's see if we have a perfect square trinomial. Okay, perfect square trinomial. So a squared plus 2ab plus b squared. So this is where if I have something like x squared plus 8x plus 16, okay, where I'm getting it doubled. So 8 and then double that is 16. That's going to be x plus 4 squared. So basically I'm going to take that middle number, I can divide it by 2 and then square it. Okay, or x plus 4 squared. And then we see that with the subtraction as well. So a squared minus 2ab plus b squared. So if I get x squared minus 6x plus 9. So we see where we've got 6, all right, and 9. So I'm going to take 6 divided by 2 and get 3. Okay, so I should get minus 3 is going to add up to negative 6. Negative 3 times 3 is going to add up to 9. So I get x minus 3 squared, or x minus 3 times x minus 3. Okay, so if I see minus plus show up here, right, I should be getting minus minus there. Okay. Difference of two squares, so a squared minus b squared, okay, where I have something like x squared minus 9. That's a sum difference, so I'd get x plus something, x minus something, okay, in order for that to happen, but it'd have to be the same things. All right, so the zero product property says that if a product is 0, then at least one of its factors is 0. You can use that property to solve some polynomial equations. We'll see some things like that later on. Let a and b be real numbers. If a times b equals 0, then either a is 0 or b is 0, or they're both 0. Okay, but those are my possibilities. That if I've got everything comes out to 0, one of those parts has to be 0. All right. Solving systems of equations. In fact, what I want to do before I go on past that is I'm going to insert a slide here. so you're aware of something, right? If I have x squared plus bx plus c, I just want you to understand we're going to get plus plus. Okay, let's actually put these together. Okay, let's say I've got x squared, let's say minus bx plus c. These help in terms of if this is x. So I'm going to get x plus, down here I should get x and x. If it's minus plus, does anybody know what my signs should be? Okay, so this is maybe what we're missing then. In order to get this middle term, in either of these cases, I'm adding these numbers here, right? I'm combining them. But to get C, I'm multiplying them, right? So if this is a plus here and this is a minus, I should get two negatives in here because negative plus a negative is still a negative, but negative times negative gives me a positive. Okay? So again, if I'm starting off with a coefficient of 1, right, that's going to help me. I know I'm going to get x, 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 x. Here it's plus, plus. That's an easy one. Minus, minus. All right. Let's see. If I've got x squared, I got bx and c. Let's see. I can get plus minus here. Okay, where I've got x and x. Okay, what do I have in this case? I'm adding two numbers up and I'm getting a positive. Okay, but whenever I multiply them, I get a negative. Anybody know how that happens? What are my signs? It has to be a negative and a positive because the only way to multiply two numbers to get a negative is to have a positive and a negative, right? Okay, but one of the things that I know is I know that the positive has to be the larger number, right? Because whenever I add them together, I get a positive value. Does that make sense? Okay. If I have x squared minus bx, let's see, I feel like we've already done that. I feel like those are the main instances. Actually, no, we can get this. Okay. It is possible to have that, and it's similar to the one that came before it. Okay, the only way to multiply and get a negative is to have a positive and a negative, correct? Okay, but how would I get this negative value over here? What would have to be true? The negative absolute value would have to be greater than the absolute value of the positive. All right, so do you guys understand the arrows there in terms of what's bigger, what's smaller? All right, so if you understand this and I'm starting out with an x squared, then I'm going to have, 1, 2, 3, 4 out of 6 parts already done. Now all I have to do is figure out the numbers, right? Does that make sense? So if I have this chart written down, all right, that's really going to help me out. Okay, because I don't have to spend so much time racking my brain over how to make this work. Okay, lesson 24. Solving systems of equations using the elimination method. We've already done this to a certain extent. Recall that a linear system with no solutions is an inconsistent system, while a system that has at least one solution is a consistent system. We've seen that chart like 5 times now, right? And we had a question about it on the test that a lot of people missed. So is that chart important to us? It's important for us to remember is when I have an inconsistent system. Inconsistent is no solutions. Consistent is at least one. It can be one or all, right? Okay? If there's exactly one solution to a system, it is independent. Okay? So where two lines crossed is going to be consistent and independent. Okay? If there are infinitely many solutions, the system is dependent. Okay, so where two lines are the same line, it is consistent and dependent. Okay. All right. If there is no solution, it's inconsistent and I believe dependent. Okay. So the solution of a system is the the solution of a system is the intersection of the graphs of the equation of the system, making it possible to describe a system just by looking at its graph. Okay. So we can look at these. This will actually help us out here. Okay. Inconsistent system, parallel lines. Consistent system, independent and dependent. Independent whenever they cross, dependent whenever they overlap. And I tried to show the overlap a little bit. If you look really close, you can see a black line or blue line overlaid with a green line. Okay, that's where two equations represent the same line. So that chart may help you out as well. Okay? Make sure there's nothing below it. All right, so now a whole bunch of reading. One method for solving a linear system is graphing and finding the intersection point or points if they do exist. Another method that we've discussed is substitution, where if I know y equals something, I can substitute what y equals into the other equation and solve for x. Okay. When the equation is solved, the value of that variable is then substituted. So if I've solved for x and I get the answer, I can plug x back into either equation and solve for y. Okay, you could also do that in reverse if I knew x equaled something, so on and so forth. The last method for solving a linear system is the elimination method. So when the elimination method is used, the two equations are added. I would argue that they could also be subtracted. Okay, I could also subtract the equations. Now what you have to be careful is if you're going to subtract two equations to use elimination, that you understand that you're subtracting. So if a number is negative, I might be subtracting a negative and therefore adding terms. Okay, so you'd have to be careful with it. But the sum of one of the variables has to end up being 0, meaning that it cancels out or is eliminated, leaving an equation with one variable. We solve that variable. Just like with the substitution method, once we have solved one variable, we plug its solution into either of the two original equations and solve for the other variable. Okay. All right. So with that, let's look at some questions. All right. Question number 1 has me factor. Now, one of the first steps it told us to do was to factor out the coefficient, the first coefficient, if it wasn't 1. My coefficient here is what? What's the first coefficient? 4. So I need to see if I can divide all of those terms by 4. Okay? Can I divide all of those terms by 4? Okay? So I'm factoring out the 4, leaving me with x squared. What's negative 56 divided by 4? So I'm factoring it out, dividing it out. Should be negative what? Negative 14. Okay, leaving me with an x because I didn't factor out an x, and now I need 196 divided by 14. Should be positive. $49. Okay, so 4 is going to stay on the outside. What I need to do is factor that down. Okay, so I've got x as my 1 is my coefficient, so we're going to put 4 on the outside here. Because it's minus plus, we should be able to go back. If you copy down those notes, we should already know what my signs are going to be whenever I have a minus plus. What is it? Minus minus. Okay? So I'm looking for two numbers that whenever I add them up, I get 14. When I multiply them together, I get 49. 7 and 7. And because it's 7 twice, can I reduce that to anything? Okay, because it's x minus 7 times itself, we represent that as 4 times x minus 7 squared. Does that make sense? Okay, does that chart that I gave you help a little bit? I wish that they would give you something like that because it just kind of makes common sense to have something like that to look at to kind of cut through some things. All right, x squared minus 81. We saw an example of this. Now, what I want you to understand is that anytime I've got an x squared minus a perfect square, okay, is 81 a perfect square? Okay, my answer will always be x plus and x minus the square root of that perfect square. Okay, so I'm going to put this up here. Okay, does that make sense? All right, so our answer then is x plus and x minus what? What's the square root of 81? 9. Now, what is nice about these, and we didn't do it with the last one, is that I should always be able to check my answer. How could I check that answer? Anybody know? How could I check and make sure that x plus 9 times x minus 9 is the answer? Foil it. So see if it goes back into this. So x times x is x squared. X times negative 9 is negative 9x. 9 times x is positive 9x. And 9 times negative 9 is negative 81. What happens to the 9x's? I got negative 9x and positive 9x. What happens to them? Cancel out. So I'm left with x squared minus 81. Okay. So was my answer x plus 9, x minus 9? Yes. Okay. You ought to look for ways to check your answers. Okay? Because our test scores are not necessarily improving. Okay? If my test scores are not improving, then I need to look for ways to assure that my answers are correct. Okay? Before I move on to another question. Okay? This is a way to check your answer, is go ahead and FOIL it back out. You could do the same thing with number 1, right? If I come back up here, right, x minus 7 times x minus 7, right? I'm getting that x squared minus 14x plus 49, multiplying all of that by 4, getting 4x squared minus 56x plus 196, right? I'm seeing that I get what I started with. I have the right answer. All right, number 3, solve using, if we wanted to solve this using elimination, okay? Okay, so the first thing that you would have to do to solve using elimination for this is get everything so that they're together, right? All right, so 1/2 x minus 3y equals 0 over 4x plus 7y equals negative 31, right? All right. The next thing that I need to do is I need to be able to get either an x or a y value into a number that's going to be opposite of the other x or y value, right? Okay, so just to help you out, okay, with this one, I'm going to multiply the top equation by a number so that I can eliminate the x value. If I multiply it by 2, 1/2 times 2 is just 1, right? Then I would wind up with 1x, but that's not opposite of 4x. I need it to be opposite of 4, right? So it's only 1/2, right? So I'm going to actually have to multiply the top equation by negative 8, okay? So when I do that, I rewrite it, negative 8 times 1/2 is what? Negative 4x, correct? Okay, what's negative 8 times negative 3? Positive 24y. And negative 8 times 0 is still 0, correct? Okay, so now I have 4x plus 7y equals negative 31. Okay, whenever I add those two equations together, what happens to the x's? They cancel. What's 24 plus 7? 31 equals negative 31, and that's a y. So what is y? Y equals negative 1. Now that I know that y equals negative 1, what do I do with that? Plug it in, right? We could come back to our original equation here. 1/2 x equals, let's say, 3 times negative 1. So 1/2 x equals negative 3. What do I do with that? Divide by 1/2 or multiply by 2. So x equals negative 6. So in terms of my answers, how do I put that into a coordinate pair? Negative 6, negative 1. Okay, that's the elimination method. It is possible that I might actually have to multiply both equations by numbers in order to get variables to cancel out. Okay? All right, let's look at number 4. Tell whether the polynomial 6y squared times y squared plus 6y plus 9 is completely factored. If it's not, we want to factor it completely. Can that be broken down any further? Yeah, no, no, yes. Yes. Okay. All right, what part of it can be broken down further? Multiplying. So are you wanting to distribute? No, you're trying to end up making it bigger. By factoring, we want to break it into primes. We want to break it into its smallest parts. Okay? What part of it can be broken down further? Go ahead, Angeli. All right, so you mean this part can be broken down further. Okay? So y squared plus 6y plus 9, okay, can become what? Well, we know our coefficient is 1, so we get y and y. It's plus plus, so what are my two signs going to go into my parentheses? Plus and plus, so I'm looking for two numbers that add up to 6 but multiply to be 9. 3 and 3. All right, well, y plus 3 times y plus 3 is the same as what? Y plus 3 squared. Good. And I still have this. I can't lose it. I have to put it on the outside. Okay? That's broken into prime polynomials. Okay? Do we see that answer up there? All right. So, is it factored completely? No. If it is not, factor it completely. So we said no, with this being our answer. Okay? Do we understand these? Okay. All right. All right. Number 5 says use the zero product property to solve x plus 4, x minus 3 equals negative 10. This actually requires a number of steps. And the problem is that this equals negative 10. So I can't set x plus 4 equal to 0 and solve for x. I can't set x minus 3 equal to 0 and solve for x because they don't equal 0 yet. They equal negative 10. Okay? So what do I need to do? I need to FOIL it and get that 10 back over with the rest of it. Does that make sense? All right, so x times x is x squared. X times negative 3. 4 times x. 4 times negative 3. Negative 12 equals negative 10. What do we want to do with that negative 10? Add it to what? Add it to the negative 12. So we have x squared minus 3x. Or sorry, we can simplify that, right? Plus x equal, or sorry, comes out to what? What's negative 12 plus 10? Minus 2 equals what? 0. Now can I factor this? I got plus minus. My coefficient is 1. So I have x and x. What signs do I use with a plus minus? So minus negative times a negative is a negative? Minus plus. Okay, now this is where I said if that's a plus symbol in the first spot, minus in the second spot, what do I know? Which one is bigger, the minus or the plus? The plus, because it comes out as plus whenever I add them together. So I'm looking for two numbers that when multiplied are going to be negative 2, but whenever I add them up, right, I get a positive 1. Does anybody know? There's only so many things that multiply to be 2, right? In fact, there's only two things that multiply to be 2. What are they? 1 and 2, right? So where do I want to put the 2? On the positive side. Where do I want to put the 1? All right, now let's check this. All right, 1x plus 2x is what? X. What's negative 1 times 2? Negative 2. So does that work? Okay, so we checked our answer. All right, finally, we need to set x minus 1 equal to 0 and solve for x. Okay, what do I do? How do I solve for x? Add 1, so x equals 1. Over here, x plus 2 equals 0. What do I need to do? X equals negative 2. The quick answer is that it's always the opposite sign, right? Okay, so we want 1 and negative 2. But that's the zero product property, okay? Because one of those, right, if I plug in 1 for x, it's going to make this 0. 0 times whatever it is going to cause it to be 0, okay? Because anything times 0 is 0, okay? Or if x equaled negative 2, I'd plug in negative 2 there. That would be equal to 0. This times that would be 0. I get 0 again, okay? Okay. All right, let's look at number 6. Do we feel like we've got that? Okay, it's going to be a plus plus, right? Should be what, 5 and 1? Right? X plus 5, x plus 1, because 5 plus 6 is 1. 5 times 1 is 5, right? You follow me? All right, so my answers are going to be what? If I got x plus 5 and x plus 1, when I solve for x, what should I get? They're both going to, if they're both positive, right, they're going to come out as negatives, correct? Okay, so we didn't have to draw that one out. Okay, let's look at number 7. What do I need to do with number 7 first? Because it's not in the form of x squared plus bx plus c, right? It starts off with 3x to the 5th. What do I do? Danielle, what do you think? Is there anything I could take out of all of those terms? What could I take out of all of it? I could take out a 3. I can divide everything in there by 3, right? What else could I divide everything by? I could divide everything by 3x to the 3rd, right? All right, well, if I divide 3x to the 5th by 3x to the 3rd, what am I left with? X squared, good. All right, if I divide 21 by 3, what do I get? 7. If I divide x to the 4th by x cubed, what do I get? X. Okay, 36 divided by 3 is what? 36 divided by 3, 12. And x cubed divided by x cubed is 0x, right? All right, so now we've got 3x cubed on the outside. Can I factor down this inside portion? Okay, it's plus plus, so I'm going to get what? Plus plus. Okay, so numbers that multiply to be 6, but add up to 7. 3 and 4, good. So 3 and 4, but don't forget, out here, we have 3x cubed, correct? So if I'm going to use the zero product property to solve for x, I actually have 3 things to solve, correct? I have 3x cubed equals 0. I have x plus 3 equals 0. And I have x plus 4 equals 0, right? Okay. Well, what is x going to equal over here? Does anybody know? 0. Because I can take 0 divided by 3. I'm going to get 0. and I can find the cube root of 0, I'm still going to get 0, right? Okay, so over here I get x equals what? And over here? Okay, so I should get -3, -4, and 0. This is the one people forget about. Okay, because we get so distracted with solving that, we get this, we completely forget to do anything with that, let alone bring it down. Or that, because here's the deal, if x equals 0, then 3 times 0 cubed is 0, and 0 times all of that causes it to equal 0. Okay? So 0 is an option. All right, so we're looking at 0, -4, -3. Get that right there. Okay? Of course, we get a lot more of these. Let's see. I want to cover at least one more question, but I want you guys to pick it out. We haven't done a lot of elimination yet, so if you want to pick out an elimination question, we've done a lot of factoring. We can do, you know, any of these over here, kind of like 10, 11, 12. If you want to do a word problem, okay, we can do 8. What do you guys want to look at? What do you think? You want to do an elimination question? Okay, good. Which elimination question do you want to do? 12? Okay, great. Okay, so this is nice. It sets it up. We've got our x's and y's on one side. We've got our solutions on the other. We just need to eliminate a variable. Okay? But we don't have anything where it looks like I can just multiply one equation, right? I'm going to have to multiply both equations, and I need opposite values for those x's and y's. So do we want to eliminate x or do we want to eliminate y? Okay, so I'm seeing x. Okay, what's the let's see, what's the least common multiple? 10. All right. Do I want my top to be negative or my bottom to be negative? So whenever I add them together, they cancel out. Okay, so I'm going to multiply by what? -5, and I'm going to multiply the bottom by +2. All right, so tell me what I get whenever I multiply the top one by -5. -10x. Okay, plus 25y equals 35. Okay, let's do the other one. What do I get there when I multiply by 2? 10x. Okay, so now I'm going to add these together. What happens to the x's? Just as designed, they cancel out. What is 25 plus -6? 19y. What's 35 plus 22? 57. Okay, divide on both sides. What does y equal? 3. Y equals 3. Okay, do we all agree with that? What do I do with y equals 3 now that I have it? Plug it in. Plug it in where? 2x minus 5 times what? Equals -7. Okay, so 2x, what? -15 equals -7. Now what? Add 15 on both sides. 2x equals 8. X equals 4 as a coordinate pair. What does that look like? 4, 3. Okay, notice that they have 3, 4 as an option because when you eliminate x, you solve for y first. People think first thing goes first. Okay, coordinate pairs are always listed as x then y. Okay, no matter what order we solve things in. We feel pretty good about elimination. Okay. Is there anything that you feel like a question that you want to cover before I close this video out? No, you feel pretty good about all that?